Hello and welcome to the flipped instructional session for Physical Science Semester A, Unit 1. Today we're looking at 1.02, Matter and Energy. As a reminder, be sure you're taking notes during the recording. You want to make sure you have all the key words. Those are helpful when you get to your Part 2 test, and just helpful as you prepare for quizzes and tests at the end of the unit. So always title your note page with the lesson number and title at the top. So as we get started today in matter and energy, just a reminder, you can access all your lessons from the content portion on your science homepage. Scroll down on the left-hand side, and today we're looking at matter and energy. So as we jump into the introduction, we talked about in our last lesson that physical science is a study of nature, of matter, energy, and how they interact with each other. So if you did not get that definition before, you may want to make sure you jot it down now. And so we're going to focus on a few simple examples, the way objects behave when they hit the ground. So as we scroll through here, we're going to take a look, and we're going to plug it into this example. We're going to drop each ball and observe how it behaves after hitting the ground, and we'll make some observations about the different balls that we see. All right, so if we take a look, it looks like we have maybe a golf ball, a pool ball, a tennis ball, and maybe a rock. Not sure what that is. So if we drop those, okay, and keep looking at it, we're making observations about what happens with the different balls. So we see that the white golf ball just continues to bounce the longest. We see that the pool ball, thinking that's a pool ball, or it could be a Magic 8 ball, but it looks like with the size compared to a tennis ball, it's a pool from the game. So very heavy, we know that just drops straight down. The tennis ball bounces. And then if this is a dirt ball or a rock, I'm not really sure, but it's pretty solid too when it hits. So how are these objects similar? Okay, we know they're round, they're a ball shaped, spherical. So after dropping them, they all eventually stop bouncing. We know that some take longer than others. And how are they different? So we know they have different sizes. Some bounce higher, some continue bouncing longer than others. So think about what some of your observations were, and see if you can answer these questions. So if you're looking at something, making observations, you want to kind of maybe guess the material that we're looking at. So we know that a golf ball and a pool ball, a tennis ball, rock, these are all made out of different things. Depending on what they're made out of is going to affect how they react. So we know that a tennis ball is made to bounce. There is some kind of elastic in there. We know the inside of a golf ball also has some kind of elastic component to it. Why do some balls continue to bounce longer than others? So if you think about maybe the mass of these objects, we could see that these that bounce longer were maybe a little bit lighter. So their mass could be a factor. And then question 4, why do all the balls bounce the highest on their first bounce and then bounce to lower heights each time that follows? So if you think about that, we're talking about energy. We know that they lose energy each time they come back down to the ground. All right, so our lesson goal today, we want to describe how scientific discoveries explain the nature of the materials that make up our world. All right, so we're moving into explore. This is the content that we need out of this lesson. So talking about matter and energy, it says, as you may have observed in the simulation, when you dropped the balls, some bounced while others did not. Eventually, the balls stopped bouncing and rested on the ground again. Some did this more quickly than others. We will continue to explore the concept of bounciness and the relationship between matter and energy in this lesson. Okay, drop height versus bounce height. So if we're looking again at the simulation, we're going to check that out and see what we can observe about the height it is dropped from and the height it bounces. So you may have to watch this a couple of times. Okay, if you're looking at it, pay attention to where it drops from. It's kind of hard to see. It doesn't seem to go all the way to the top, right? It may be 70 or 80 centimeters. It's hard to tell. So how high does it bounce? It never gets back up to that initial drop height. Okay, so does the ball ever bounce higher than the release height? In this case, no, it does not. Okay, and then how can you get the ball to bounce the highest? So you know when you want a ball to go really high in the air, you have to put a lot of force on it. So it says either you can release the ball from the highest possible point, and that would make it bounce the highest. So increasing the height, or you could add some force to it. And then how could you make the ball bounce the lowest? If we're thinking about that, releasing it from just above the ground, a lower drop height is going to be a lower bounce height. So what general statement can we make about this is that the release height of the ball determines the maximum bounce height of the ball. So height and energy. When you raise the ball off the ground, you give it some potential energy. When you release the ball, the energy is turned into motion. And we know that that is kinetic energy, and we'll study that later in the unit. So we have a little problem to look at here. Consider dropping a ball from the top of the Empire State Building, which is 1,250 feet tall. How would the energy of the ball when it hits the ground compare to the energy of a ball released from 1 inch above the ground? Okay, so we're comparing how the energy of that ball when it hits the ground compares to that of the ball released 1 inch from the ground. Okay, so don't think about the energy at the top as it drops, because that has a lot of energy. Think about right when it hits the ground. So a ball object dropped from 1 inch is going to hit the ground with more energy than one dropped from the top of the Empire State Building. So that may have been the opposite of what you were thinking, but you have to think of how much time it had to lose energy. So the longer it has, the more energy is released. So how does this relate to your observations about the bounce height and the release point? So objects that are dropped from greater heights can bounce higher because they start with more energy. So that makes sense. So why do they stop bouncing? The perfect bouncy ball would continue to bounce to the same height from which it was dropped forever. So what causes bouncy balls to come to a rest in the real world? We know that some energy is absorbed by the ball with each bounce, and this heats up the ball. So while we can't see this change in energy, the energy is going somewhere. So remember, we have always energy transferring all the time, back and forth. So what makes something bouncy? Some balls are not as bouncy as others. Take a look at this slow motion video of bouncy balls and make some observations about what happens to the shape of the balls as they collide with the ground. So if you're looking, you can see some of them hitting the ground. You may not be able to clearly see, but you can see a little bit of change in shape. So observation 1, they compress a little bit as they hit the ground. And 2, they return to their original shape after compressing. So it's just the slightest change, and then it goes back. So what makes something not bouncy? Now observe this ball as it's dropped and compare it to our observation on the other one. Okay, so look at this one. All right, we didn't see a lot of bouncing. It definitely went up and landed again. It seems like it was heavier. So it doesn't really compress and spring back like the other one did. So the ball does not compress. It says, or the ball compresses, but it doesn't expand back. So the bouncy ball definitely has some kind of elasticity, right? So the material of the ball affects its bounciness. Materials that are elastic are bouncy. Elasticity is the ability of an object to return to its original shape after being stretched or compressed. So that may be something you want to write down. Objects that compress and return to their original shape very quickly are bouncy. Other objects, like pillows, might compress and return to their shape, but they take longer to do so. So that makes them not bouncy. And materials like clay that compress but do not expand are not bouncy either. Rigid materials that do not compress are not bouncy and sometimes break when dropped, like this glass plate. So no compression, right? You can just see the plate shattering. All right. The amount of air inside a hollow ball affects its bounciness. So if you ever tried to play basketball with a deflated ball, it doesn't work very well. The air inside the ball compresses and expands when the ball hits the ground. If there's not enough air in the ball won't bounce. The elasticity of a ball is important in sports. So would you use a tennis ball to knock over pins in bowling, or would you use a bowling ball in a tennis match? The elasticity, size, and mass of the ball are important properties. Remember, the word properties means like a description of something, and those must be considered when you play a sport. All right, so that is the end of 1.02, Matter and Energy. So make sure you have your notes together for that lesson. And then the next steps for you will be to look for a flip follow-up. You should see one on your schedule a week for science. You're welcome to come into a help lab if you ever have questions or need extra support on anything. And have fun. We'll see you next time.